My name is Hong Ban. I'm a research assistant at the University of Mexico for Professor Andrea Poli. My position with her lab has been to create these kind of biology equipments out of really affordable materials. The equipment can range from microscopes to spectrometers to magnetic stirrers, and my main role has been to fabricate and kind of make iterations and improvements on the designs of these types of equipment that were initially designed by Peter from the BioHack Academy with the Vogstein.
Okay, so what are we looking at here?
This is a sterile hood. Basically, it is a device that you are able to work in to make sure that you're working in a completely sterile environment. It pulls in air from the back compartment and pushes air through a filter or filters into the main working area, which is where you can test out your petri samples or whatever it might be to ensure that there's no kind of stray bacteria going into your cultures. How this one works right now is using a kind of really easy computer fan, and all you do is turn it on as it pushes air through the hood and through the filters. So this is an example of something that's usually several $1,000s in the professional world to get a sterile hood, but you can create one for under $50 US.
What's it made out of?
This one is made out of medium density fiberboard, so MDF. It is a wood that is available from Amsterdam. We created the rest of our hacks using kind of other materials such as chipboard or a really thick cardstock.
What else is included as part of that? You talked about the fan. There's
Yes. Well, there's the connection pieces. Everything is done without using glue or any special kind of connection device. It's just, or any nails. It's all done with these kind of really intelligent screws that were designed in. And these kind of just sit in there and hold everything together, which is really nice, not just for simplicity, but because if you need to transport this anywhere, it's incredibly easy to just take apart and put back together. No tools really required.
what kind of filter is that?
This one is a HEPA filter. It's a typical filter that you find in the air purifier in the office.
And if you could change anything about that, like what are some of the revisions or the variations you think would be useful if this was, this is kind of a biohack, right? So
Right.
What would you hack about this?
What I would love to hack about this is to make it a little bit more streamlined. I don't think the two compartment approach is working well. It'd be a lot nicer if it was just one singular compartment, less parts to join together. The more joints you have, the more likely it can fail. I would also like to put in a light in the working space just so you can see what you're doing. Just small things that really make it a lot easier to use, not necessarily better, worse.
Is it scalable?
You can absolutely shrink it down if you wanted to. This is really just great for human scale because the design of this is made so that you can place your petri dish in here to cultivate your samples in the space and ensure that it's absolutely sterile. That way you're not getting any stray bacteria or any odd material into your sample. So when you take under a microscope or when you're examining it, you're not getting something odd coming up. This is a really great scale to work in just because you have a space where you can fit both of your hands into. You can work in the space without having to worry about bumping into anything or hitting something. It's just the right size for one person to work in. You could absolutely scale it up too. I mean, a professional grade sterile hood is the same exact idea. It's just with a lot bigger components, a much bigger fan, a much bigger filter, more filters. So it's relatively the same approach. So,
Better.
right. I mean, this is by no means what we would use for, say, medical grade, but
Oh, yeah.
I think for just understanding how to go through the process and become inspired about
Yeah.
process of cultivating bacteria culture is really great. And there's a lot of practical approach for this, not just for the art side of things, but if you take this, take it to a country that doesn't have access to this kind of material, it's really a wonderful piece of equipment.